Okay, I think we are live this morning. Good morning, everyone. Welcome to I think this is the 11th, if I'm not mistaken, town hall that we've done. It's amazing. So we've been going for quite a while on Reskill Americans program, and we're coming into the home stretch for the course material that we've been giving everybody. So I believe the last courses have either dropped this weekend or will shortly drop for everybody. And I realize some people are maybe a week or two behind and trying to catch up. So we are going to assess this week when we start the project period, uh, and so we'll kind of talk to everybody about where they're at and get a feeling for how people are doing. So good morning, Juwan. How are you doing? You have anything to say?
Yeah, good morning, Mike. It's great to be here, and we're also happy to have Dev join us. It's really exciting that we're in the last stretch of the program. I know that a lot of people have been putting in a lot of work just to get to this point, and we
Yeah.
really appreciate that. Like Mike said, we're assessing where everybody's at, and we're basically trying to see, how we can help everybody. So if there's still something that you're struggling with, feel free to reach out to me. Feel free to reach out to any of the mentors and see how we can help you remove any impediment and help you get to the.
Yeah, that's great. Okay, why don't we get started with today's guests? We have Dev Nambi, and he is a data scientist working at the Fred Hutch Cancer Research Center. Good morning, Dev.
Good morning.
So, I think we chatted a couple weeks ago, and I learned a little bit about your career path. But maybe you can talk a little bit about what does it mean to be a data scientist, and what is that? What kind of things do you do on a daily basis?
Sure. So let's see. I suppose, at least at Fred Hutch, the big part about being a data scientist or data engineer is you're always asking questions, and you're usually asking questions with, research scientists and oncologists and statisticians who are incredibly focused on the science and the medicine, but the software engineering part of it isn't their forte. That isn't what they're trained for.
Yeah.
Um, So I would say being a data engineer at Fred Hutch, probably the big focus is you need to be able to hold up all of the engineering side and know enough of the science and enough of the cell biology to be dangerous. That's especially true in this era of, well, basically computational intensive medicine. Most medical research right now is fairly data intensive, especially on the cancer research side, because we have much better tools right now to do things like like sequence every single cell in a tumor and see how they grow and evolve. That's amazingly powerful. It also involves a huge amount of data and information. So a lot of my job actually involves working with different labs. Fred Hutch has dozens of different labs doing different kinds of research. And usually I end up getting partnered with a research team that is doing some really interesting science. And they've managed to make it work for small little samples and experiments. And now they're trying to scale it up.
Mhm. Yeah, I think I have my idea of just kind of data science in general is looking at computing trend lines of trying to find correlations in data sets, large data sets. Um, it sounds a lot more advanced than that, though. Like it's not just basic statistics. It seems like it's and the data is, I think you were describing, is not necessarily easily structured by standard tools as well.
That's certainly true for cellular biology and genomics, which is my main focus. The reason is because standard statistical tools don't work particularly well when it comes to DNA. And the reason is if you have 3 billion fields, trying to find statistical significance would require sequencing every cell probably on a population larger than this planet. It's basically impossible to do. So standards, so the old term for it is the curse of dimensionality. If you have, if you're trying to predict a value and you have 4 different inputs, like 4 different columns of fields, you can do that. Standard statistical tools will do that. If you do it with a few hundred, it's not that hard. If you do it with a few thousand, you start running into data problems. With a couple billion, and it's effectively impossible. So a lot of the tools that exist for genomic work are very specialized. The algorithms are very specialized, and they tend to exist as command line tools. It's similar to other data science that I've done in other places, in that it starts with what's the business problem, like what's the scientific problem, what's the problem you're trying to solve, and can you take this generalized problem, like does smoking affect one of the teams I'm working with right now is trying to figure out, does smoking affect individual cellular DNA, and if so, by how much? And can you actually test this? Can we take a blood sample, sequence their DNA, and say, okay, your cellular DNA is damaged this much. We could tell that smoking has done this much damage to you. You are at this risk of like lung cancer in the future.
Oh, that's really interesting, because I guess in the past we'd come up with these kind of very big populations and look at correlations, but like, okay, people who smoke tend to get cancer more frequently.
Right.
But it sounds like you're saying, after you have, a few packs of cigarettes, you can look at some cells and say, are they starting to have a higher level of mutations than other cells in your, in your otherwise healthy lungs?
Right. So that's the sort of scientific or business question. And then it gets translated into a research question, which is, do we have enough data? Do we have the right kinds of data? Can we actually use this data and manipulate it enough that we can actually get a valid result? In that way, what we're trying to do is exactly the same as any other data science problem. The idea of a perfect data set to answer a question, it's easy to define one. They never exist. You're always dealing with imperfect and incomplete data sets. And so the question is, given this incomplete information, can you come up with reasonable answers anyway?
And I think is another aspect of your job helping scientists kind of communicate their findings and to visualize and represent, in a way that other scientists can understand their work?
That's part of it. There are traditional methods of doing that. Like the famous traditional method in scientific communication is a research paper. Right. And so with a research paper, you have standard, 2-dimensional static visualizations. Scientists are trained on how to do that. That's old school. That's like pretty much everyone knows how to do that. There's great tools for it.
Charts and graphs and things like that.
Right. However, we're in an era where the amount of data you can communicate to another scientist can be orders of magnitude higher than a research paper. We can make websites that literally have, here's a visualization of every single cell we've sequenced and information about them. So that kind of data intensive visualization it's available now. The tools for it exist. The training for scientists on how best to utilize that is still in its infancy. So that's part of my job for sure.
Oh, so like, would you even give like other researchers interactive access to drill in on information that they want to see, that how it relates to their own research?
Yeah. So this exists right now. If you go to viz.fredhutch.org, you'll see some examples of cellular atlases, which is we'll sequence millions of cells and we'll turn them basically into a visual atlas of here's how different cell populations behave. And you can actually split it apart by like, oh, I'm interested in this gene because this is part of my research. I'm interested in this type of cell because this kind of cell is part of my research, and you can see how it behaves.
Wow.
It's all anonymized and private, of course, but if there's no personal information attached, there's no reason you can't make this available and make it useful to lots and lots of stuff.
Yeah, that's amazing. So like, instead of a research paper, you have to like publish an app basically on the web that other people can use.
Website. I mean, the papers
website
are there too. Paper submissions are very much the bread and butter of all scientific research. Those still exist. it's very common nowadays for data intensive research. In addition to the paper, they'll have a link to like a GitHub repo with all of their code and a link to all of their data. That's pretty common now.
Oh, wow. That's cool. Well, let's take a step back, because I think a lot of people are interested in just how one gets started in a career as a data scientist. And I think your path hasn't necessarily been very linear. You just kind of started in doing some different things. Is that right?
Yes, that's very true. In one aspect, my path has been fairly traditional. I got a bachelor's degree in computer science and math and statistics. So that, in that sense, it's pretty much
Yep.
perfect for data science. But that was 20 years ago, back when the term didn't exist. My first job was as a network engineer at a startup. I was doing system administration, and it turns out the databases were the ones that always had headaches. So I ended up teaching myself SQL, teaching myself how to query and look at data. And then it turned out that a lot of the software engineers that I was working with, when they were working on data intensive problems, they didn't have a background in statistics. So they were amazing software engineers. They are amazing software engineers, but they didn't know enough statistics to be dangerous. So that's probably the main thing. Like there's this famous example about, famous quote about data scientists, which is they know more about software engineering than any statistician and more about stats than any software engineer. You have to know multiple things. And that's probably been the thematic thing with a lot of my career, which is when I'm jumping around between, working at a startup, working at Microsoft Research. I was working at the University of Washington as a research analyst for a while. Being, not the best, nowhere near the best, but being good enough to get a lot of stuff done in multiple areas of focus. So software engineering, statistics, and the business domain that you're working in. That really is the benefit. That really is what you need to be good as a data scientist.
So you can't be like you really do need to understand like the questions people are asking and understand how it relates to the data. You can't just be kind of like a pure abstract data scientist without really starting to learn something about how to talk to your clients or customers.
Yeah, those kinds of data scientists do exist. They tend to be almost pure like algorithm developers. So they tend to exist in larger data science teams. So this goes back to one of my mentors had this brilliant analogy of, if you go back to the early 2000s, you had web developers, and their job was to be able to create an entire website ranging from like the back end, the PHP or Python or JavaScript code, the UI and UX development, security, all of it. You have to take care of all of it. Finding people with those skills was pretty rare. And so what happened really quickly is people started to specialize, which is true. But now you have back-end engineers, you have front-end engineers, you have UI and UX developers and designers, you have security and infrastructure folks and DevOps folks. That one role basically fragmented because people with one skill were pretty rare. So in larger teams, you'll find people who are like data analysts, you'll have people who are business experts, you'll have machine learning specialists, you'll have statisticians. But those are much larger teams. Those aren't as common. Most data scientists end up working in small teams or working alone, at least right now.
Oh, okay. I did not know that. Cool. So I think when we chatted earlier, you were talking a little bit about kind of how to build your chops and in terms of like working with data and stuff like that. And we were talking about like what would you recommend as people who are considering like going into this field? Like, what should they be doing? How can they get some experience and start to build the experience working with data and answering questions like that?
Sure. Well, the practical answer, the short version is do lots of projects. Do projects that interest you, do projects that are personally compelling, because that way when you get stuck and frustrated, you'll keep going. A lot of the best data engineers data scientists and data engineers I've spoken with are stubborn. They're curious and they're stubborn. Because as I'm guessing everyone who's seeing this, who's in Reskill knows, one of the classic definitions of a software engineer is you make some progress, you hit a wall, you get stuck.
Yeah.
And then using your own cleverness, your intuition, just sheer persistence, you find a way over or around or under this wall. And then you keep going. And then a few minutes later, you get stuck again. And if you're able to do that, if you're able to keep going, then you end up making progress and building something. Most of the data science skills and data engineering skills I either learned on the job, so persistence is kind of a given, I get a paycheck for it, or what's more common is I was doing side projects. I was researching food, I was doing research on food, on buying a used car, on land development, you name it. It was things I found personally interesting. So I would do these side projects and I would end up learning techniques that I'd never had the chance to try out myself.
That's cool.
And that's really what I'd recommend is pick a.
So you just had a curiosity,
subject.
a question about something, and you were able to find like open source data or openly available data sets?
A lot, either there were openly available data sets or I ended up making them. So I ended up writing a blog post series on how to buy a car because my car broke down and I know I didn't know what to do because I'd never purchased one before. So I'm like, well, this is kind of a data problem. There's lots of cars for sale, lots of information about prices and how long they live. Can I turn this into a data problem about what are the most reliable cars, and then what's the best way to buy them?
Oh wow!
And in doing so, I ended up learning about like agent theory and adversarial learning and reliability statistics and things and Bayesian math, just because I had to for this project.
Where'd you get the data for that?
Sure. So information about car reliability you can find all over the place. There's a site called Dashboard Light, probably the best source of it. Information about car prices, Craigslist and AutoTrader and TrueCar and stuff like that. You can find prices on what's available in your town easily.
So were you scraping websites or just doing some manual data entry?
I was a little bit. Honestly, a lot of it was manual entry. I was doing the old school way of, I had websites available and I had an Excel file open. I was just copy pasting a lot of raw information.
Okay.
The second time I did it, I wrote a website script. But
okay. So this project wasn't necessarily like a massive big data problem, but it was you had enough data to compare.
Yeah, I ended up looking at 500, 600 different cars.
Okay, okay.
Which
is more than most people would consider in buying a car.
Right. But again, this was the thing that it took me. It was a couple of weeks of focused effort because my car was in the shop. It was basically dead. I needed another vehicle just to get to my job. And so I had a really strong incentive to do this work during my off hours.
Mm-hmm. When you're interviewing and for follow-up jobs, do you ever talk about your side projects and like that with interviewers? Are they interested in stuff you've done on your own?
Yes, although it turns out I usually don't bring it up. So one of the things that I'd recommend doing for everyone is if you don't have a lot of job experience in a particular field. So if you're starting off as a data scientist, you don't have job experience, especially from boot camp. Make a blog, write about your projects, post the data publicly, post the code publicly as much as you can. So usually what I have on my on my resume whenever I'm applying is I'll have my name and I'll have my website right below it. Mm-hmm. And most of the time when I get to an interview loop, whoever is hiring me has looked at the site and is like, oh, okay, I'm interested in buying a used car, or I'm interested in like cooking. You did this really interesting sort of small research project, small post about this. Talk to me about that. So it's a great way to basically market yourself as having some useful skills, even if you haven't gained those skills during a 9-to-5 job, during a day job.
Oh, that's awesome. Yeah, it's the power of like building a portfolio, both for like developers that are building sample applications and showing off the things they've done. But it's interesting to hear. I hadn't really thought of like you could take these data science projects and turn them into blog posts and sample code and your analysis and stuff like that. That's really cool. Someone on YouTube said, Chris Franklin said, I'm doing a Kaggle data set project. Do you know what Kaggle is?
Kaggle, yeah.
I don't know what that is. You can explain that in a second. On credit card fraud detection with other developers. We use Pluralsight as the video tutorial source and we have a GitHub version control for the project. Yeah. So what is Kaggle and what is he doing?
Sure. So Kaggle is basically a data science competition site.
Oh, nice. Okay.
So the idea is that you could have companies, they would provide a data set and they provide an incentive, a prize.
Okay.
And the idea is anyone can sign up to be part of these competitions. They have, rules for here's the data set we're giving you. Here's how you're going to be judged against a hidden data set that you don't see. You can submit your code or submit your results, and we'll judge them. And the winner gets, a prize. The famous early example of this was the Netflix prize.
I remember Netflix had $1 million for their recommendation engine. Yeah.
Yes. That was kind of the genesis, the early idea of this. Kaggle basically commercialized it. So now there's lots and lots of examples. It turns out that if your goal is to be really good at machine learning, Kaggle is a good place to get started. It is a bit artificial in that with Kaggle, the data set is given to you and it's clean.
Ah, okay. What does that mean?
So probably 95% of the work of data science isn't statistics and machine learning. It's acquiring and cleaning up and enhancing data. So you have data in 14 different databases, or it doesn't exist, and you have to go scrape the web, or it doesn't exist and you have to go do surveys or put sensors out into the world and get it. That's the hard part. And cleaning it up to the point where you can actually run Python code against it, or run TensorFlow code against it. So that's 90% of the work. That's why there are more data engineering jobs than data scientist jobs, because data engineers do that work, and that's most of the effort.
How do you know you're not ruining the statistical relevance by cleaning? Like, what does the impact of cleaning have on data?
Usually you're working with data scientists with some statistics stuff to be able to do that.
Okay.
That's why this has to be a collaborative effort. You have to know statistics to be able to do it, which is when you're cleaning up data, you have to be sure, like, okay, if I'm imputing values that are missing, am I going to mess up the statistical values? Well, that's a good problem. So that's definitely part of it. With Kaggle, that work has already been done.
Okay.
The company that's creating these competitions has already cleaned up the data for you. So it's an extremely useful way to get some chops at statistics and machine learning. On the data engineering side, you're not going to learn much because the work's done for you.
I see. Okay. So it's just kind of part of that, I guess, data pipeline that you would have to build for any project in terms of how,
it's usually
how you're going to process data.
Right. It's the last bit of the pipeline. And it's a great place to learn that, but please be aware it's not everything.
All right, cool. Well, let me, I don't know, is there any other kind of advice, but we'll get into some questions from our participants, but I don't know if you've had other general advice. I like your advice about doing your personal projects.
Probably two. The first is, if you're going to do personal projects, pick topics that have broad relevance. So things that if you talk to a stranger off the street, they'll be interested. So some of the most popular posts I've ever seen about personal data projects involve things that almost everyone interacts with. So they're dealing with like weather or traffic or beer or prices on Amazon products. I think that's partly why my used car posts turned out to be popular, because everyone has this headache. Buying a used car is a pain in the butt for pretty much everyone, and finding a data intensive way to do it is interesting to basically anyone who's hiring for software engineers. So I'd suggest if you're going to do personal projects, pick a topic that is both personally interesting to you and also has broad relevance. The second bit of advice I'd give is actually kind of in the same vein, which is if you're going to go from a boot camp to be a software engineer or a data scientist in industry, pick the industry ahead of time, or at least pick one or two. So that question where they were looking at credit card fraud and financial transactions, that's a great thing to post about if your goal is to work for a financial company.
Yeah.
Because that's going to be relevant to them. if your goal is to work, let's say at a scientific research institution, that isn't quite as relevant.
Mm-hmm.
So I'd say pick personal projects and pick an industry, because doing projects that are relevant to them will help you get an interview. And the other thing is, from what I've heard, a lot of the folks going through Reskill their background isn't in computer science. They're retraining for another job.
Yeah, that's true for a lot of people. Yeah.
In some ways, that's your great advantage, because, for example, my lack of biology and healthcare knowledge was actually almost didn't get me hired. Like, I had to be really good as a data engineer to get hired. So in that sense, if you have a history in a different industry, whether it's construction, whether you've done food service jobs, so you know about foods and kitchens, you did what I did, which is you were a driver for a while, you know about transportation and maps. That's a big advantage. A lot of pure software engineers don't have that experience, don't have that intuitive history. And so if you pick an industry that is adjacent to what you've previously done, but has a more high-tech focus, you're much more likely to be able to get a job, because you already have a wealth of experience and a wealth of knowledge that other interviewees don't have.
That's a great point. So I guess, so you had to do a lot of kind of on-the-job learning. I know I tell people a lot that being a software engineer is it's all about you're constantly learning. Like, it's not just in the boot camp and say, oh, I've learned everything I need to know, I'm done. There are all kinds of new systems, new ways of building software and stuff like that. And but it sounds like in your experience, it goes kind of a level beyond that. You're having to learn biology and a lot of scientific stuff. How's that been going for you?
It's easier now that I've got I have some of the fundamentals down, but early on it was rough. The first 6 months of my job at Fred Hutch were kind of a blur, because I talked my boss into paying for a couple of Coursera courses. So during the day I was working, and during the afternoons I was taking these courses. I have a couple of friends that were going to nursing school. They still had some of their old textbooks, so they lent me some anatomy and physiology textbooks. So I was reading literally about, like, here's how the human body works, because I didn't know. In that sense, I have a lot of catch up to do. But your point about software engineers having to retrain is very true. And I haven't done a study on this, but in my personal experience, the skills that I learn are highly relevant for maybe a year and a half to 2 years, and then I find
Oh boy. Wow.
The fundamentals are similar,
Yeah.
but the tools, the applications, the really popular packages evolve quickly.
Yeah. I kind of always felt like, as a developer, like, when you kind of get on the train, like, as a JavaScript developer, say, there's the state of the art in how you're building apps and so on. But new things are coming down the pike all the time. But being kind of on the train already, like, everybody kind of recognizes, like, the way we do things now is broken because of X. And they're kind of waiting for, like, a solution to come along, and then, like, here comes React or something, some library like that, and everyone recognizes, like, oh yeah, that solves a big problem. I've been beating my head against the way I've been doing that in the past. So it is a lot of constant learning, but I think having that your perspective of being you understand why there's been a shift, because it is kind of a problem you see all the time.
Right. So that's a great example. So if you go back, I don't know, 5 years, React was not as popular. Back then, Angular was still relatively popular.
Yeah.
Vue, I don't think it even existed back then.
Yeah. Right.
And so knowing JavaScript was useful then, is still useful now. Same with jQuery, things like that. Being able to deploy a website, and then when it breaks, walk through a browser developer tool, like walk through Chrome developer tools, and figure out how did this break? What's going on? Like, how do I fix what's going on? Being able to iterate and test and fix out bugs. That's useful then. That is even more useful now. So those core techniques and tools still broadly useful. Being amazing at Angular and absolutely, brilliant at jQuery, not as hireable now.
Yeah.
Still useful. Probably a lot of the techniques will translate, but those specific skills don't translate quite as well.
Yeah. Yeah. I mean, if I see jQuery on a resume, I get like, okay, well, they've been programming a while, but new projects, you don't see it pop up as much because it's not needed really anymore.
It's still quite useful. It's just not the best tool for many different situations.
Yeah, that's true. All right. Well, let's, Juan, did you have any questions? I'm just going to look on Slack to see if we have some questions from participants.
Dev, thank you so much. That was really insightful and impactful. I think the piece that I really enjoyed the most was because I did see your resume website, and I thought that was really cool. And like, I think it has a different perspective because like I've been on the hiring side before, and sometimes like it boils down sometimes to not being sure, like, can this person really do what they're saying? Like, a resume is fine and all of that, but having practical examples, like you rightly said, I think is amazing because it goes deeper than just having a skill. It actually shows a lot of other soft skills that you probably aren't able to just put on a 2-page or 3-page resume, if that makes sense.
Mm-hmm. Yeah. Almost all software engineering is done as part of a team. It's extremely rare to be the only software engineer, the only data scientist in any technical role. You're always working with other people. Probably the most useful soft skill by far is communication. Can you talk to other people? Can you communicate technical concepts in an intuitive way, both to other highly technical audiences and not? And that's especially true with data scientists. If your goal is to say, like, here, I have this complicated bit of data, I will be able to tell a story about it that a business person will intuitively understand, even if they don't know statistics. So communication is a very important soft skill. Almost nobody writes about that on their resume. People don't value it. People don't value, like, it's not a bullet point that you can easily put. It's not a like technology term that people look for, that recruiters look for when they're hiring. But hiring managers are going to care about it, even if they don't articulate it as such. And again, writing about something is a form of communication. I've seen people that have actually made YouTube videos where, and I haven't done this myself, this is not my forte, but they have a data problem, and they actually talk through, here's what I'm doing. They have a screen showing up and they're like, here's me literally doing code, and you can see what I'm doing. Oh, I got stuck here, I'm going to work on that. It's amazing. It's amazing to see these people do that. I'm honestly a little nervous about doing it because I make so many errors that I haven't done it yet. But that's, again, being able to communicate what you're able to do is hugely important. And honestly, a lot of software engineers aren't amazing at that. They're brilliant at like looking at code, figuring out what's going on, adding something, but they don't communicate it quite as well. And that's a really important skill.
That's great. So we had a question, was kind of about just, I think, like tools and languages. What is kind of in your toolkit now, or when you started, and what kind of tools do people need to learn?
Sure. Well, my current focus is mostly using Amazon Web Services, so AWS for its cloud computing capabilities. So I have to know a lot of their offerings and be able to know which ones work well.
Mm-hmm.
I use Python really extensively, and I use Bash, like Linux in the command line, for a lot of my work. And again, that's partly informed by my job. So I have to be able to work with, complex genomic tools. They're almost always command line tools, and they always run on Linux or Docker containers. So I have to know Linux and Docker and command line tools. There's usually scaling headaches, and how do we go from 1 cell to a million and a half cells? Okay, so cloud computing is required for that job. Python is great for infrastructure code because it's such a good glue language, has libraries for everything. So the languages I use most for my job are the ones that are kind of dictated by what's required. Looking at broad developer surveys, so for example, Stack Overflow and RedMonk both have these amazing developer surveys about like, here are the most popular languages on like GitHub or Stack Overflow, and you can see like what's in the top 10. Typically, JavaScript is up there, Java is up there, Python is up there. For data-intensive research, it's very often Python. Java and Scala are in there a little bit depending on what language you're doing.
Oh, really? Okay.
What programming. Scala tends to be decent, especially if we're dealing with like Apache Spark, which is mostly written in Scala.
For what is it?
Apache Spark, which is a distributed data processing language.
Okay.
Scala is basically a functional language built on top of Java. It's a little esoteric, but it turns out to be quite useful.
Yeah. I have friends who know Scala, and it seems like black art to me looking at their code.
Honestly, to me too. My more general advice is if you know what industry you're looking for, if you know what job title you're looking for, go look at 30, 40, 100 different job descriptions.
Yeah, because they'll lay it all out in there.
Right. They'll say, here's what we're looking for. Here's the basics. Here's the desired qualifications. And just make it tally. Turn it into a data-intensive project.
Oh, that's fun.
Which is, what are the... So you can kind of think, again, this shows my own bias, which is, I think of this as a data problem. What are the most common technologies that hiring managers and recruiters are looking for? And they tell you. It's public. You can go to Indeed, you can go to LinkedIn, you can go look at job descriptions, and you can find out for yourself. So if you look, so let's say, for example, you want to work at Google. Chances are machine learning is going to be way up there. Chances are, Kubernetes is going to be fairly high up on the list. If you want to work at Facebook, React is going to be up there. If you want to work at a research institution, chances are R is going to be way up there because it's so heavily used by researchers. So my general advice is think about what kind of place you want to work for, what industry, what size company. Find these places and then start looking for their job postings because they tell you what they're looking for. Do a broad search and you'll find out.
Yeah. You mentioned Bash scripting. This is like I think when I was at Google, I wrote an embarrassingly large amount of Bash scripts. I thought it was like, what am I a JavaScript developer or am I a Bash developer? Because we're doing stuff like document production, building our kind of our own pipeline for production pipeline for documentation for different versions and things like that, and you just end up pulling out Bash a lot. And yeah, I got embarrassingly good at writing Bash scripts, so probably wouldn't put that on my resume, but
honestly, I probably would. I haven't updated my resume a little while, but if I do and I'm looking for another research institution, I'll be like, I'll probably write up there great at Bash, and I'll show some examples because it probably holds a significant part of the internet together.
Yeah, it's such a clunky language kind of in a way, but yeah, it's fast to implement stuff.
Right, and it runs natively on Linux, which means chances are if you're running any sort of like Linux system, which is most of the internet, it's a lingua franca. It's just going to work everywhere. I mean, that's the reason why JavaScript is so popular, is because it works in every single browser in the world.
Yeah, I just finished. For fun, I was reading the Brian Kernighan, the guy who wrote the C programming language book, the original one. He has a new memoir talking about the early days of Unix development at AT&T Bell Labs, and just all the very small number of people that created Unix, and they were building tools for themselves too, like doing document production. That was like one of the big things they were doing. So yeah, but those are really old tools, but they have survived the test of time, I think. Someone is asking about the difference between maybe skill sets for a data scientist or a data analyst. I'm not that familiar with those kind of job descriptions.
Sure.
Do you understand that?
Yes. So depending on who you talk to, you'll get different answers about this. The sort of classic definition I see is data analyst jobs typically don't involve large amounts of data. So the amount of data, a lot of the data analyst jobs I'm looking for that I've seen are evolutions from the old business analyst job descriptions, which is they have to have a lot of knowledge of the business domain.
Okay.
And a lot of the work is done in data volumes that you probably fit on your laptop. It's an Excel file, it's a CSV file that's 10 megabytes, 100 megabytes. You can fit it into working memory. And it almost never involves machine learning. It'll involve some stats. It might involve a little bit of programming. It'll probably involve a little bit of SQL, but the amount of software engineering is not required is not huge.
Okay. So I think of like something like Microsoft BI or Tableau or
yes,
Excel and pulling in data. So you're doing some data cleaning and data massaging in order to get it presentable to like use some visualization tools and things like that.
Right. So if you think of the product that gets created, a lot of data analyst jobs, your product is going to be reports or visualizations or dashboards.
Mm-hmm.
That's kind of the classic definition.
Yeah.
With a lot of data scientists, that might be your output, but a lot of the things you might be creating are products. You'll create a recommendation engine. You'll do image tagging. You'll do what is it? You'll end up like driving like analytics that are built into websites. So you'll end up doing something that has many more code components. You'll probably do a little bit more machine learning as well.
Okay, great. Someone is asking about the R. You mentioned the R programming language. Someone asked, do you think it's dying for data science?
Do I think it's dying for data science? No. The short answer is no. And the reason is because R is incredibly popular in academia. It's incredibly common for research papers for the data analysis done for a research paper to be done in R.
Now, what does R do for you that Python doesn't? Or is there some? I'm sure there's some overlap, but maybe
there is a lot of overlap.
Packages in Python, I'm sure, that do statistical analysis.
The short answer is R. There are R packages for incredibly specialized research.
Okay.
Because it's relatively easy to make an R package. I think I actually made one at one point, and it took me about half an hour to basically walk through a tutorial, and I made an R package that anyone could download, which is kind of scary. Python is great if you're working with other bits of infrastructure. If you're working with AWS, if you're working with Linux, if you're working with some common statistical methods, it's great for that. If you're doing something fairly specialized, so for example, let's say you're doing oceanographic research. Chances are there are several dozen R packages specifically aimed at oceanographic research. Because there have been academic researchers that did that. Python doesn't have that. Python is an amazingly good general purpose programming language because of its library support. The number of packages that Python has for fairly specific use cases is nowhere near what R has.
Oh, interesting. Okay.
R is a much older language. It's much more idiosyncratic in some ways, which is why it isn't as popular. It doesn't scale nearly as well. It's really hard to do multi-threading with it. But because it has so many packages and such great support for like esoteric use cases, it's incredibly popular in a certain area. What I often see is people will, if you go back, if you take any particular business domain, whether it's operations research, image analysis, oceanographic research, cancer biology, whatever. If you go back to an early enough point and you go to research papers, you'll find R and R packages pretty much everywhere. Once it gets to a certain level of popularity or a certain level of scale, the gaps in R start showing up, and then people will often rewrite it or re-implement it in a different language.
Okay. Some other languages people are mentioning, just as we're talking about languages, as Dart and JavaScript for data science. I don't know if you have any thoughts about that.
I don't know enough about Dart to be able to comment on it, so
Okay.
I'm sorry I can't really help you with that one particularly. JavaScript for data science is a little newer. I've seen little bits of it.
Mm-hmm.
It is useful in a few ways because if your goal is to be able to do statistics or machine learning on a person's computer,
Okay, right.
then it's potentially really useful. Like, let's say you want to, if someone's uploading an image and you want to be able to tag images and do object detection, being able to do it on that person's browser is great. So that makes a lot of sense. However, that's a somewhat limited use case, and currently, from what I can tell, because of the way JavaScript is written, it's an event-oriented language. There's been huge amounts of work done to make it compile and run quickly. It's still nowhere near as fast as compiled languages like C or TensorFlow that's compiled down to C.
Yeah. Although, yeah, it's like even with WebAssembly, like you can write. I mean, in the browser, you can get stuff that's maybe only twice as slow as native C, which is
Absolutely
amazing in a browser. Yeah,
and
so I guess
works.
TensorFlow has, like Google has a TensorFlow that's all built in JavaScript.
Right.
Yes, doing like what you're talking about, running machine learning in a browser. Yeah, because then you don't have to you don't have to provision like a bunch of CPUs in the cloud for your clients to use it.
It depends. So I'm going to go with
Okay.
So if your goal, if we go to machine learning, there's a few different classic steps. There's training, there's testing, and there's serving.
Mm-hmm.
So training is you're trying to build a machine learning model and you have a large data set.
Okay,
so to do that, you need dozens or thousands of cores to do it. It tends to, I mean, GPU-based learning is really popular because it has some really specialized utilities and it works really well for that. To do that well, you need a large data set and a lot of compute, and you need to be able to have these compute units talk to each other quickly. So that is basically tailor-built for cloud computing and compute clusters. You will almost never run that on a single person's laptop because their laptop will melt. It doesn't have the CPUs. It doesn't have the CPUs or memory to do it. So you'll almost never see that written. I have never seen that written in JavaScript because that's not what it's best at. Doing test validation is similar. Once you're serving the results, you have a model built and you have individual inputs that you're trying to compare with the model to see if it works. The computational resources for that are much lower. And that makes so much sense to do on someone's edge device. You want to do it on somebody's smartphone, you want to do it on somebody's browser. Running data science utilities in JavaScript there makes a lot of sense. So I can definitely see that becoming more and more popular as time goes on.
Mm-hmm.
I have a hard time imagining it's ever going to become the dominant language for data science because some of JavaScript's just sort of inherent limitations around large-scale compute.
Yeah, and Python is so well adopted now; it's hard to imagine it being dethroned in any way. But so people are asking about, I think, a little bit about like qualifications for a data scientist or analyst, and in particular, a degree or certification. Do you think that's necessary, helpful? What's your take on that?
Do I think it's helpful? Absolutely. So
I mean, you had a
Again, 10 years,
math and statistics degree, right? So
right. I kind of lucked out in having the right having some of the right qualifications for data scientists before the job existed. That was pure luck. There have now been data science certificates and degrees and master's degrees and even doctorates that you can get that exist right now. They're newer programs, but universities are offering them.
yeah,
So if your goal is to get a data scientist job, that's kind of the simplest sort of classic approach to do it. It's so those that will be helpful.
yeah. And just to be clear, like Reskill Americans doesn't have a data science track. Like it's I know it's an area of interest for a lot of our participants, and especially the ones that are learning Python now.
At the same time, I think right now we're in a bit of a transition point as far as the industry goes. Because again, if you go back 10 years, there were no data scientists academic credentials. They didn't exist. So what a lot of hiring managers were looking for, and what they still are looking for to a broad degree, is do you have the skills? So because you couldn't get the exact skills you needed from a certificate program, from a degree, they're like, okay, well, that's impossible. We can't look for that. So do you have the skills some other way? I mean, the simplest way to do it is, have you done this already? There's a reason that for a lot of data scientist jobs, they're considered more senior level positions. What the requirements are looking for is you need to have several years of experience with Python, with stats, with SQL, with data science, with doing data science already. What a lot of hiring managers are really looking for is, do you have the actual skills? Like, if we put you in this job right now, can you do the job? So in that sense, I would say, a boot camp is helpful.
Are there like other online classes that you think are good, like in Coursera or something like that? Do you know?
Some of them. I think I'm going to go with maybe. So, and the reason is, I've hired for a lot of data engineering jobs because Fred Hutch was hiring for data engineers for a while before the pandemic hit. And the resumes were all over the map. We had software engineers that were taking statistics courses that were applying. We had people with actual data engineering credentials. We had folks from boot camps. And by and large, what happened is, if you had some of the qualifications, like you've done Python, you've done some SQL, you had a GitHub, like people who had GitHub profiles or blogs where they actually wrote about some of the work that they were doing, almost always made it to a phone interview.
Okay.
Because they went above and beyond. It's still considered above and beyond to have a blog, to have an online presence that shows your work. So that's probably the main thing I would suggest doing. If you're going through a boot camp, spend $10 every year, buy your name. Like, for example, mine is devnambi.com. That's my name, that's my blog. Buy your name online. Put a blog in front of it, put GitHub pages behind it, something, and write about what you're doing. If you're going through an academic course, great. Write about that. If you're going through a Reskill or another boot camp, write about that. If you're doing a personal project, write about that. Or Coursera courses, the same thing. It really depends. It depends partly on the industry. It depends on the job description.
Yeah, I know, like for the machine learning, like I guess like famously the first massive online courses were machine learning courses that went out of Stanford, and they had tens of thousands of people enrolling in those. I don't know how many actually finished them, but
less than 20%.
Yeah, the self-paced online learning is hard. It's hard to stay motivated, hard to keep up. Which I'm very impressed with the people who are at Reskill Americans who are still keeping up and working hard. So hats off to you. Know that you're in the 20% category of people who are sticking through with things. It's so. But yeah, I could see that there'd be a lot of people like going through courses like that. I don't know if you ran into people who did graduate from those courses in your hiring. whether you thought that transfer of experience and knowledge was good with a course like that.
So yes, I did. We actually hired or went through interview lists for some folks that had just come out of boot camps,
Okay.
and the ones that we gave offers to, and the ones that actually, had multiple offers, they took it fairly seriously in the sense that they saw the boot camp not as just like, I complete the courses, I update my resume, and I'm done. They're like, it was very much, they completed the courses, they were able to talk about their project, they took their project, and many of them actually took it a step beyond when they were done.
Just put it into practice and be really
a little
curious
bit
about it, using it.
Yeah.
Like that. Yeah.
Curiosity and persistence are very necessary in a software engineering job. They're some of the sort of curiosity, persistence, and communication skills.
Okay.
Are probably the three big ones that I look for. And that shows up. That shows up in the people that you hire. If you're interviewing for a place and you've got that and you are sort of showing that in your resume, even if it's not explicitly listed, it's gonna translate.
Great. Well, I think it's great advice for everyone. I think I sat down with you this morning thinking we were going to spend a lot of time talking about data science, but I think you've given a lot of just really solid kind of career advice, how to focus your like communication skills and being able to present yourself, and I think it's super helpful. So thanks for being thoughtful about that.
Sure.
All right, Joanne, do you have anything else? I think we've kind of let me go back to the YouTube stream, see if there's let's see. Oh, there's a few things here. We have a couple more minutes. Yes, some people are using R here. That's cool. People are asking about test-driven development and unit testing. Oh, and also what data visualization tools.
Okay.
Do you use any of those things?
Sure. Yes. Let's start with data visualization tools.
Yeah.
A lot of the best data visualization tools right now run, well, it's kind of split into two camps. There's BI tools. So Microsoft BI, Power BI, and Tableau are kind of the big ones there. And there are tools that are basically rendered onto a browser that are using open source utilities. So the oldest one is called D3. Most visualization tools that run on websites are built on top of D3. So some of the big ones that I see now are things like Plotly or Altair. Chances are, so the simple way to figure out what visualization tool is going to work well is go and find web visualizations you like, look at the source code, and see what library is important.
Yeah.
I would also, and one of the ways that I do this is I'll find a simple visualization problem, like, can I build this scatter plot? And I'll try and build it using 4 or 5 different visualization libraries and see which ones work best. Plotly works really well. Altair works really well. D3 works, but it's a complete pain in the butt to try and program.
Okay.
And so trying that gives you a decent sense of like, oh, okay, if these utilities work relatively well, they're going to become more popular because developers are going to use them. So that's probably the viz side of things.
And there was testing.
Yes. I don't see the terms test-driven development or unit testing quite as often. The big thing I see right now is what's called CI/CD, or continuous integration and continuous development, which is still test-driven development in the sense that you're still writing tests, but instead of running them on your own machine, what happens is the minute you check in, like it's because so much of software engineering right now is done with like immediate deployments. Like you're deploying to the web, there's no reason you can't deploy 40 times a day. And so what'll happen is you write some code, it's in a GitHub repo. As soon as you hit commit and push it to GitHub, a continuous integration server will start running. Yeah, it'll trigger, it'll run all the tests that you tell it to run. And if they pass, it'll auto deploy it to a website. That's really the current standard right now. So again, if your goal is to go for a more like slightly more software engineering heavy job, try it. There's a lot of things like Circle CI and other tests and other CI/CD pipelines. They're free. They're free for a modest amount of use. So again, give it a try. Try writing a little app, write a few tests for it. It deploys to a website. Give it a try, see how it works, get used to it, write about it.
Yeah, cool. Yeah, so it's CI, continuous integration, or CD. Is that right? So continuous deployment.
Yeah.
So one last question, but is Fred Hutch hiring, and where is there a website people can go to look at job listings? Do you know?
Sure. So we are hiring. If you go to Fred Hutch, if you just do a Google search for fredhutch.jobs or fredhutch.org, you'll see the jobs link. We're not hiring as extensively as we were a couple of years ago. The short version is because of the pandemic.
Yeah. And do people required to relocate to Seattle to work at Fred Hutch?
It depends. So Fred Hutch is in the middle of figuring that out right now.
Yeah.
So some jobs absolutely have to be done in Seattle. So for example, a lot of our labs are wet labs. They involve people working with sequencers or test tubes. You kind of can't do that at home. It's done on the Fred Hutch campus.
Yeah.
So those jobs, you do have to be in Seattle to do that. The other jobs that are more IT focused, you're doing computational biology, you're doing software engineering, you don't have to do those on campus. I haven't been on campus since last February. So right now they're being done remotely, and the company and the organization's actually going through this big sort of learning process to figure out, should we offer jobs remotely forever? Because communication is harder, but at the same time, a lot of people at Fred Hutch have moved away for a year. They're living in places with a lower cost of living than Seattle.
Okay. Yeah.
And I mean, the company's definitely thinking about it because, you know, you could hire more people. You can hire from people that just aren't living, that don't live inside Seattle, and their salary will stretch further so that they'll be more comfortable doing it. But there's a communication sort of challenge involved with that.
Yeah, I think you're right. Like every company is really kind of trying to figure this out now. What's going to be what's the new normal?
Yeah, and I keep hearing people going back and forth. Like I think at one point Google's like, okay, everyone has to come back on campus, and now they're saying, oh, some people can actually work remotely forever. So I think companies' remote work plans are still evolving.
Yep. I think that the big outlier is Amazon, which seems to be very focused on getting everybody in person back into the office. But other companies, not so much. So, all right, Dev. Well, I appreciate spending the hour with you, and it was so useful. You know, thank you so much for all your insights, and yeah.
Happy to help.
And I wanted to also quickly chime in. So I've shared Dev's resume on Slack.
Yeah.
So if you wanted to take a look at that, just to get some inspiration on how you could go about developing yours as well, I think that would be great. And I'm happy that you also touched on that, because some of the things that we've been trying to get participants to do in the last couple of weeks is just to put out more of their work on like LinkedIn, Twitter, wherever it is, because there are even certain people that are within your network who might see what you're doing. You know, other people. Reskill Americans is like a very typical example of this. More than 70% of our participants come from word of mouth referrals. So that's a very powerful tool, that just putting it out there in your network and do.
Yeah, I've heard from participants that they're starting to get more visibility on LinkedIn, and people are kind of aware of what they're working on. So yeah, so it's great.
I think you mentioned earlier that you're going to doing some project-based work.
Yes.
Pretty soon.
Yes.
That's perfect for this. That's absolutely perfect for this.
People could blog about their projects, and yeah, totally. So yeah, so we'll be prompting people to kind of think about what they're interested in, and we have some other project ideas that if you're having trouble with that. But yeah, that's great. Okay. Well, thank you very much, and I'm gonna end the live stream here. And so have a great week, everyone, and I'll be heading back to Seattle this afternoon. So, but I'm in California now. But okay, all right. See you all later.
Thanks for the chance to talk.
All right. Thanks, Dev. Bye.